let's do some proofs with our parallel lines and the angles and all that fun stuff. Now it's going to get more interesting. All right, so copy this down in your notebook. Pause it now, copy it down, then we'll talk about it. All right, so in this picture, angle 1 and angle 2 are supplementary. We need to prove that the lines are parallel. So remember, we learned 4 ways to prove that lines are parallel. We can use corresponding angle converse of the postulate, alternate interior angle converse, consecutive interior angle converse, and the alternate exterior angle converse. So if we just look here at what we have 2 and 3, which we know those are corresponding angles, and really I don't see any other special pairs of angles with the lines in that figure, right? So if I am already given that 1 and 2 are supplementary, I know I talked to a couple people about that little trick, seeing that when they give you angles that are supplementary and they're not adjacent, probably the best thing to do is, okay, let's try to find a relationship between supplements. So we know for our next step that angle 1 and angle 3 are supplements by the linear pair postulate. You can see that in the figure, that 1 and 3 are supplementary. And then again, so we're thinking about how to prove lines parallel. And we said the only pair that we see here that are a special pair would be 2 and 3. So we actually have that angle 2 and angle 3 are congruent if we look at our 2 previous statements, because they're supplements to the same angle. So that would be the congruent supplements theorem. Angle 2 is congruent to angle 3 by the congruent supplements theorem. Meaning, if 2 angles are supplementary to the same angle or equal angles, but in this case same angles, then they are congruent to each other. And then we are finished with our proof. Line 1 is parallel to line 2 by the corresponding angle converse. Make sure that you're writing converse when you're proving the lines are parallel. Here is our second example of a proof involving parallel lines and angles. So copy this down in your notebook, pause, and when you're ready, restart. All right, so we're given that the lines are parallel, CD, and we want to mark our sketch with parallels, right? So CD is parallel to AB. Now, if the lines are parallel, when 2 parallel lines are cut by transversal, then what do we know? We know that we have certain angle pairs. So we can see here, there's that Z, right? The Z angle. So that then tells me that angle 1 is congruent to angle 3, and that's going to be our second step. That angle 1 is congruent to angle 3, and that's by the alternate interior angle theorem. Not its converse, but rather its theorem, because we already know the lines are parallel. We were also given, in our given information, that angle 1 is congruent to angle 2. Okay? Remember what I always say about those double markings there. When you have those double markings, that's going to lead you to a substitution. Angle 1 is congruent to 2, 1 is congruent to 3, so we could link those 2 angles together and we are finished with our proof. How easy was that? Angle 2 is congruent to angle 3 by substitution. Nice and easy.